In this video, I want to talk about the passive sign convention. So in previous video, you saw that how we can define the positive and negative reference directions for current and also reference polarities for the voltage, right? So they were generic descriptions. But the final goal for the circuit analysis is for us to come up with a mathematical model. So basically the voltage or current of individual elements by themselves is not that important, right? The way that they interact to create more complete equations is the one that is important for us. So because of that, we need to come up with a plan to assign the reference polarities for the voltages and reference direction for the currents. So the way that we do it is, you can say, entirely up to us. Whether we want to use the positive values as described in the previous video, or whether we want to use the negative values. However, once you decided on the references, both the reference polarity and the reference direction, you must write all the subsequent equations to agree with that chosen reference. So you cannot do this differently for the different components of a single circuit, right? Whatever standard you come up with, you have to follow that for all the components. Otherwise, your solution is going to be wrong. But there is what is called the passive sign convention, which is very common in practice. So I highly suggest you use the passive sign convention. Even though it is up to you how you can choose the reference polarity and reference direction, the passive sign convention is what is very common in practice. So what does it say? So to explain it a little bit better, let me just quickly draw a circuit element like this. So we have 1 and 2 here. So the passive sign convention states that whenever the reference direction for the current in an element is in the direction of the reference voltage drop across the element, we use a positive sign in any expression that relates the voltage to the current. Otherwise, we use a negative sign. So what does it mean? So let's just say we have this circuit, and let's just say I assign the voltage direction, the voltage polarity to be like this. So the positive is terminal 1 and negative is terminal 2. Now let's just say I assign a current in this direction. So as you can see, the direction of the current is in the direction of the voltage drop, right? So the current goes through the terminal 1 and then comes out through terminal 2, right? The direction of the current is in the direction of the voltage drop. So for this case, whenever we want to show the relationship between the voltage and the current, we use a positive sign. On the other hand, let's just create a similar ideal circuit, but let's just only switch the direction of the current. So I use the voltage polarity like before, but this time I decide to use the current that goes in this direction. So as you can see, the direction of the current now is in reverse of the voltage drop, or it is in the direction of voltage increase. Based on the passive sign convention, whenever we want to include the equation associated with this element in our model, we use a negative sign. So some of these things that I am describing here, they might not make sense to you at this point, right? Because these are the foundations upon which we build our mathematical models, right? So when I talk about more advanced techniques like Ohm's law, voltage law, current law, you will see how these schematics that I used here are going to be used. But for now, keep that in mind that we will be using the passive sign convention throughout this course. So in this short video, you learned the passive sign convention. Later on, you will see how we can use the passive sign convention to have a consistent way in writing mathematical equations for the electric circuits.